Thank you.
Just before we start, I think it's just important to everyone that if you could please turn off your cameras and keep your microphones on the muted function, because it's going to be better for the recording and also for the course. But whenever you have a question, if you feel free to open your microphone and then ask something. But while we are presenting, I think it's good to have the microphone unmuted.
Yeah, for questions during the lecture, you can probably put your any questions that you have in the chat. Also, Christian and Jefferson, you should be able to, like as needed, mute anyone that might have a hot mic on. So, hi, welcome to Integrated Environmental Data Management Solutions Applied to Mining. My name is Nicholas Lyle. I'm the lead trainer at Waterloo Hydrogeologic, which is the company that developed Hydro GeoAnalyst. With me is Christian Prees, who is the team manager for data management at Water Services and Technologies. Thank you all for attending again. And again, sorry for the technical issues. Still, I'm blown away with the number of people who registered, and I'm happy to see that so many people attended. Before I jump into the slides, I just wanted to mention that there's another webinar tomorrow from 3 a.m. to 6 a.m. There's some confusion about this. These are covering the same material. So if you're attending this one, you don't need to attend that one. Additionally, as you know, we're bundling this webinar with the 30-day trial license of Hydro GeoAnalyst. Within a week or so, Waterloo Hydrogeologic will be sending out an email, and there will be a link to the web portal where you can claim that trial license. So look out for that email. And again, if you have any questions during the lecture, just put it in the chat, and we'll try to get to all of them. So the agenda for this webinar, first, I'll be going through just a general introduction, talking about the problems of data management. In the first section, I'll be getting into what these challenges are specifically and what's important to address them. Then I'll hand it off to Christian, where he'll talk about basic concepts of data management. We'll go through a step-by-step of how you actually implement an integrated database. We'll talk about the data management software, specifically Hydro GeoAnalyst. We'll talk about reporting possibilities, such as using Power BI. And we'll give a practical demonstration of how this is actually done in practice in the software. So in this webinar, we hope to illustrate why integrated data management is essential for hydrogeological and mining projects, talk about some theory behind databases, and give a demonstration of how it's done in practice. So making decisions about the real world is a multi-step process. We need to gather data about it, process that data so that we're confident in its quality, assemble all of our different data into one synthesized model, and analyze this model for patterns and interconnectedness. So first, we collect and assemble our data. In the mining and hydrogeological context, this is often stuff like lithological profile, soil characteristics, groundwater levels, and so on. However, this data often has problems with it. Often it might be in different units. Your data might have different formatting. It could have unreliable measurements in it, and so on. It's necessary to perform quality control on our data, converting incompatible records and deleting poor quality ones. This step converts our raw measurements into information. Once we've done this, we can synthesize our information into a database that gives us a global view of the site. And finally, we can begin to see patterns and make inferences about how our data is interconnected. That is, this is how we can actually draw insight about the site, starting from our raw data. This entire process is called business intelligence. So over the last few decades, the amount of data being generated has increased exponentially. This implies that for a given amount of data, the amount of time that we have to make decisions about it is decreasing at an accelerating rate. These advances have been driven in advances in computer networking, automated data collection, and computer memory and resources. This explosion of the amount of data available for analysis has sometimes been called the fourth industrial revolution or Industry 4.0. This presents opportunities for smart decision making, but it also creates the business necessity of adopting modern data management practices just to keep pace. So in the context of mining, we can look at an example of water wells. So for water wells, you might have operational data like the groundwater level, drilling information, lithology profile, physical and chemical analyses done at the site, aquifer tests, and elevation data, pumping flow rate, so on. You also might have environmental data, so things like precipitation, soil characteristics, aquifer characteristics, so on. And these will be in different formats, so they might be saved as PDFs, saved as spreadsheets in Excel, might be diver data, or even just saved as text files or something like that. So all these different data are related. For example, pumping rate depends on the groundwater level and also on precipitation volumes and aquifer characteristics. The results of aquifer tests are obviously going to be related to your lithology profile, as well as your drilling information. And your groundwater level might be connected to your physical and chemical analyses. So as you can see, we're comparing many different types of data with different units and probably stored in different formats. This is difficult to do manually if all this data was just something that you had sitting on a hard drive, which leads me to the next topic, which is the common challenges in geological data management. So general challenges that you'll face, one of them is actually finding where the data is. So, this might mean where on your hard drive it is, but also maybe, what authority has it, which I guess leads into the next point, which is that, someone else might have the data and you will need to collect it from them. The data, as I said, might be in different formats, spreadsheets, text files, PDFs, and so on. This data might have units of measurement or different units of measurement, meters, feet, gallons per minute to CFS to cubic meters per second. And data might have different ways of naming different things. So one station might have several different names in your data, which if you don't do any quality control on it, can make analysis extremely difficult. So here I'm going to hand it off to Christian. He'll talk about basic concepts in data management. Stop presenting. Oh, whoops, wrong team. Oh my gosh. Apologies, I still have the other meeting open. It's making this very difficult. Okay, Christian, go ahead.
Can you see my screen?
Yep.
Okay. So thank you, Nick. So I'm going to talk now a little bit about some basic concepts on data management, because we think, in our opinion, it's very important to know these what we call the basic concepts before we start talking about Hydro GeoAnalyst, because I imagine that that Hydro GeoAnalyst is a software to administrate, to work with a database, and as we've been seeing with our clients, we think it's very important before working with AGA to know these basic concepts. So that's why we want to talk about them before showing you Hydro GeoAnalyst. So first of all, I'm going to talk to you about the differences between traditional data management and integrated data management, the difference between the two of them. So what we call the traditional way is all the Excel files that we have in our computers, the PDF files. That's what we call the traditional way. That's when you don't have a data management system. So you have unconnected database, you have no standards between all your files. You have unreliable data because you can have different files with the same data or with sometimes with different information. You can have redundant data, and you can have your data stored in many different kinds of files, or Excel files, text files, PDFs, pictures, or papers. You can have in many different formats. And this way, you spend much more time organizing your data whenever you need some information. So you're going to gather all this data, all this information in different formats, and then you have to standardize everything. You have to check if you don't have redundant data. So you spend a lot of time organizing your data. And then because you spend so much time organizing data, you have less time to interpret the informations that you have. And the probability of errors, they are bigger because you don't have this information control on the data that you're working with. On the other hand, if you have an integrated database, you're going to have a central database with all your data inside that database. The data available can be used in multiple projects, so you can have like many different projects in different locations, but with the data, all the data inside the same database. And all this data could be accessible by a network, so you don't need to have like many computers, or each data is in a different computer, or with a different person. You have a central repository of data, and everyone has access to this database and in a network. And you have also the quality control of your data that is inside the database. And this way, it facilitates with the data visualization. You can make integrations or automatic reports from, you can have automatic dashboards from Excel, from Power BI, or other programs that are integrated with your database. And whenever you have new data in your database, all these dashboards, they are automatically updated. And this saves a lot of time. And you have the security of your information, because you will always know where your data is, where your information is. You don't And your information will be safe. You don't have the risk to lose everything. And you have more reliable data because you have this quality control inside your database. So why do we choose integrated database rather than the traditional one? uh, when you have a large amount uh, of data in many different formats, so then you can put all this data, all these formats inside the same database. That makes it easier for you to work. When you have multiple projects and constant changes, so let's say you work for a company that have different projects in different locations, you could have, for this same company, could have one central database with all the data from all the projects. So you can have also some integrations between different systems also. And also you can establish some standards. So for all your data, you can establish a standard to put a name for each station. You can have a standard for names of your parameters. So iron, the parameter iron, I want to always call iron. I don't want to call it FE, like abbreviation. I don't want to call it total iron. I don't know. You could have a lot of different ways of writing the parameter iron. So you can specify a standard, and in all your database, it's going to have that name. You can have standards also for units of measurements and so on. And the information will be available more easily for you. So you can have automatic reports, automatic dashboards that updates automatically after you import new data in your database. And also you can have different levels of permissions in your database. Some people can have access to read the data. Some people can have access to edit the data. You can also do that. And when we talk about this integrated database system, it's also important to know what's a relational database, because in HEA, it's a software that works with an integrated database, and it's a relational database. And what's a relational database? So let's say you have like these 5 different tables of informations of data. So you have drilling data, you have registration data, you have lithology profile, flow rate data, groundwater level. So you have all these different informations, but they have something in common, which is the well name. So the well name is present in all these tables, and this way you can have you can see a relation between all these tables. Because from this table here, you get the information for drilling data for this well. On this table here, you get the coordinates and other informations for this well. You have the on this table the lithology information. So you have a lot of different informations for the same well, and in different tables. And this makes and like all these tables, they have this column in common, the well name. So then you can have a relation between all these tables, and that makes a relational database. This is a very simplified way to explain it. Of course, there are some other technical stuff when we talk about relational database, but I think this is the most important thing that you should know when we talk about relational database. And we have some, like the most used database systems on the world are Oracle and SQL Server. They both work with relational database. They're both SQL servers. SQL is a language for programming, and it's the most used for database. And it allows you to have a data security. You have some permission rules for different groups of people. You have the possibility to integrate your data with all different systems. So they have a lot of advantages when you work with SQL Server. And HA works with Microsoft SQL Server. That's the one that HA works with. And after we talk about relational database, one other concept that is very important to know is primary keys. Uh, like the first time that you see this concept, the primary key, it's a little hard to understand, but as you start working with databases, with data, it gets more familiar, because the main objective of a primary key is to guarantee unique values in your tables. And so you cannot have, for example, two primary keys in the same two primary keys that are exactly the same in the same table. So they consist of a single, they can be one single column, or it could be two columns that you can select to be the primary key of that specific table. So for example, on this registration data table, this is the table that we use to register all the points that are all the wells that we monitor in our specific area. So you cannot have two wells with the same name. So the well name here is a primary key of this table registration data. The well name is the primary key because you cannot have two wells with the same name. You can have two wells with the same coordinates, with the same x coordinate, but they can have different y coordinates. They can have the same y coordinates, but different x coordinates. So you can have wells with the same elevation. You can have wells with in the same city or same location, but you cannot have two wells with the same name. So this is why this will be the only primary key of this table. Now, when we talk about groundwater level, on this table, so imagine a table and a spreadsheet on Excel. So each of these lines here, they're the columns. So you have a column for the well name, you have a column for the date and time of your measurement, and you have another column for the groundwater level. So in this table, so let's say you have like a 10 monitoring points of groundwater level. So you have 10 wells, 10 different wells, and for each well you have, let's say, you have a measurement for every day. You have one measure for day, and you have 360 measurements for the whole year, for last year. So each well name is gonna have 360 lines in your table. So you can so this table on this table here, you can repeat the well name. You can have the same well name in different lines because you have one measurement for each date of the year. So you have one measurement for the 1st of January, another one for the 2nd of January, another for the 3rd of January, and so on for the same well name. So what you cannot have on this table is for the same well in the same date and time, two different measurements. This you cannot have. So this is why on this table, the primary key will be the well name and the date and time. If the primary key would be only the well name, so in this table you would be able to put only one measurement for this well. So you would not be able to put more measurements, only one. But you have more measurements because you have a measurement every day, once a day you have a measurement for that well. So you want to have more data for this same well name, but the only rule here is that you cannot have two different measurements for the same data in the same time for that specific well name. And that's why these two fields here, these two columns, they become the primary key. So again, it's a little hard to understand when you first see it, but once you start talking or working more with data, it gets more familiar. So in these examples here, in these tables here, this would be like all the primary keys here. And so just another example. So let's say I have this on this table here that we have the well name, date and time of measurement, flow rate, and measurement method. On this table here, I would not be able to put these two lines here because they are the same well names, PR01, in the same date and time. We have two different flow rates here. You cannot have that because these two columns here are the primary key, and you cannot have two different measurements for the same date and time for the same point. Now, for these two last lines here, they are okay because you have one measurement for the 2nd of January and you have another line here for the 5th of January. They have the same flow rate, but that's fine because they are two different measurements for two different dates. So it's okay to have the same flow rate for different specific dates and times. So these two lines here, they would be okay, but these first two lines here, they are not okay because you cannot have two different measurements for the same date and time in the same point. And then, so now one big benefit on working with relational database is that it facilitates the search for different information that are in different tables. So let's say, for example, that I'm analyzing groundwater level in a specific area. So I want a a table with the well name, the coordinates, the date and time of measurement, and the groundwater level. And I also want a column with the geologic information of that well. As I'm working with a relational database, it's very easy to get that data from my database. And then I would have, as a result, this table here with the well name, the coordinates, date and time, groundwater level, and geologic formation here. And this is a benefit on working with the relational database because you can get different informations from different tables. Now, when we talk about implementing a integrated database, we have a step-by-step that we have to work on before having our database system. So I'm just going to show you here just a little presentation on what are these steps that we have to make before implementing a database system, integrated database, before start working with Hydro GeoAnalyst. So the first step is understanding the data that we will be working with. The second step will be defining the table structure of our database. The third step will be define the standards for our data, standards of units of measurement, standards for parameter names, standards for well names, and so on. We need to make a validation of all the data that we have before importing in the database. And finally, we can do the analysis and the visualization of the data that we have, and we will arrive in the business intelligence. So first, understanding data. That's the first step that we need to work on when we implement a data management system. So first, we need to understand what kind of data do we want in our database. So I have a lot of, so in these examples here, I'm working with with groundwater information, with wells information. So I want to have all this operational data, groundwater level, drilling information, lithology profile, results for aquifer tests, pumping flow rate, and so on. And I also want to have some environmental data that I'm going to analyze with our operational data. So I'm going to analyze the precipitation, soil characteristics, aquifer characteristics, and so on. Just some examples here. So this is the first step to understand the data, to analyze what data that we want in our database, because sometimes like we have so many information, so much data available, but we don't need all of them in our database. For the purpose of our database or for the objective, maybe just a few examples of data we need in our database. We don't need everything, so that's why we need to define what we want in our database. And once we define what kind of data we will put into the database, we start the second step, which is the table structure, to define the tables of our database. So we will have, for example, a table specific for registration data to register our points of measurement. So this table will have the well names, the coordinates, the elevation, and specific informations of our wells. We're going to have a specific table for lithology data, have a specific tables for construction data of our wells, so drilling information, casing, screen, annular fill, and other tables that we could have. And we could have also TOC history, for example, if we are working in a mining pit where our TOC is cut sometimes, and then we have different TOCs on specific periods of time. We can have elevation history of our field. We can have a table for flow rates, for volume, for groundwater level. We could have a specific table for aquifer tests, for physical chemical analysis, pump placement history. So we could have many different tables in our database. We just have to define what kind of data we want, and then we define all the tables that we're going to have in the database. And then we define the primary keys of each table. And once we have all our tables like well designed and with all the fields that we will want in our database, we will see that all these tables, they're going to have something in common, which for example will be the station name or the well name. And this makes it possible to have a relation between all these tables and to create this relational database. And then finally, once we have our database defined, our table is structured and everything, we can start to define some standards for our data. And this is a very, very important step to define the standards of our database. So for example, we always recommend people to define some standards for well names or for station names, and because it's common to find like names like this, P1, P2, P3, PM1, or just numbers 12501, like some codes that once people look at the code, they cannot really think of what kind of point is this. Like people get lost a little bit, or maybe sometimes the points, they change their name and the history of this name changes, they are lost, and it's something that we find. So we always recommend to create some kind of standards of the names of our points to make it easier to identify what kind of point we are dealing with. So for example, we could establish some abbreviations according to the type of the points. For example, piezometers will have PZ in their names. And also to avoid duplication of nomenclature if we have different locations. So let's say we have a mine that is located in Waterloo, we have another mine in Ontario, we have another mine in Vancouver. We could define a abbreviation for Waterloo, which will be WM, Ontario will be OM, Vancouver mine will be VM. So we can define some different abbreviations and then once we see the point name, we're gonna know what kind of point it is and from which location. So for example here, I know that this point is a piezometer that is located in the Waterloo mine. I know this is also a piezometer located in the Waterloo mine. And this is another piezometer, but it is located in the Ontario mine. So looking at the name of the point, I'm gonna know what kind of point it is and in which location it is, and some other information that are interesting for my study, for example. So it's a lot different from this table here. Like P1, we have no idea what kind of point it is and in which location it is. 12501, like this code here, when I look at it, I have no idea where it is located or what kind of point it is. So it's much more easy to work with this. So it's something that we recommend people. Another thing that are very important is to establish some list of values. So for example, station type. So if it's a pumping well, how are we going to store this information in the database? Are we going to write everything like pumping space well? Are we going to abbreviate it like pump well or P well, PW? Like, or we're going to use underline, we're going to use a dash. So we can have a lot of different ways to write the same information. So we have to define now, from now on, we are always going to use this first option here, pumping space well. This is how we're going to write when we are talking about a pumping well. The same for lithology, for parameters, so like dissolved oxygen. There are a lot of different ways to write this parameter here, but we need to define one way that we are going to use in our database. So let's say, no, from now on, we're going to record all the data for dissolved oxygen. We're going to write this way here. So we need to define some values that we're going to accept in our database. And also, very important, to define the units of measurement. So if we are putting some flow rate data in our database, we need to define in our database, we're going to use cubic meter per second, cubic meter per hour, or liters per second, or pounds, or whatever. Pounds, like for the parameters, are we going to use milligrams or micrograms? Groundwater level will be in meters or centimeters. So we need to define, or inches, or whatever. So we need to define what units of measurement are we going to use in our database. This is very important. And just as an example on why is it so important. So let's, for example, benzene here on EPA, the maximum, the limit is 0.39 micrograms per liter. Let's say we have a result of 0.3, but we don't know the measurement unit. So and then we think it is microgram per liter, but in fact it is milligram per liter. So you see that this is a lot different. So 0.3 milligram per liter is equal to 300 micrograms. So let's say that I thought this was microgram per liter, and then I get this result, and I think it's okay, it's fine, because I'm below the EPA limit. But I forgot to see that it was actually milligram per liter, and I'm way above the EPA limit. So it can make a big mess when we don't know the unit of our database, and it's very important to define these standards. Also for groundwater level, if it's meter or centimeter. And sometimes we receive some Excel files with some numbers for groundwater level, and we don't know if it's the elevation of the groundwater level, if it's the depth, like we don't have that information. So it's always important to have everything clear. And also, this is very important to pay attention on the date format and decimal separator. In some countries, we use the standard day, month, year. Some countries use the standard month, day, year. And this makes a lot of difference because this could be the 1st of February or it could be the 2nd of January. So we need to define in our database which will be the standard. Is it going to be day, month, year, or month, day, year? We need to know that. And also the decimal separator. In some countries use the comma here as the decimal separator, and some countries use the point as decimal separator. And in countries that use comma as decimal separator, the point is the separator for thousands separator. So this would be 300.67, and this would be 300,000. In the opposite, when you use the point as a decimal separator, would be 300. This would be the 300.67, and this would be the 300,000. So it makes a lot of difference also, this. And we always face this problem because here in Brazil, we use this comma as a decimal separator, and we use day, month, and year. And whenever we receive data from our clients that are in countries that use the opposite, and we need to pay a lot of attention to don't mess, so we don't mess all the data and all the information. And some general tips: it's always good to avoid some special characters when you put data inside your database. Now, after we finish the standards definition, we can start validating and importing data in our database. So it's a very important step also. We need to be sure that all the data have been standardized correctly as we defined on step 3. And we also need to make sure that we don't have duplicate data in the data that we are going to import in the database. And we need to make sure that the data makes sense. So we need to, for example, we cannot have a pH of 30 because we know that pH varies from 1 to 14 or 2 to 13. And if we have a pH of 30, we know that we have a mistake here. So in all our data have to make sense. Or if, for example, I know that the groundwater level of my region is usually around 50 meters, and then I have a result here of 300 meters. So I know that this is probably an outlier or something wrong with the measurement. So we need to make a quality control of the data that we are importing before importing in our database. And whenever possible, it's always good to have automated processes to import data in the database. This makes it a lot more easier to have access to the information. And once we have all the data in the database, we can start analyzing. It's our last step here to do the analysis and visualization of our data. Finally, we arrive at the business intelligence of our information. So this visualization we can see in plots, in dashboards, or some indicators that we can calculate. We can see the well profiles of the wells that we have in our database. We can see the information in some maps. We can have cross sections of our area that we are studying. We can have 3D visualization and so on. And then now I'm gonna show you why do we recommend the use of Hydro GeoAnalyst. So we finally arrive in the Hydro GeoAnalyst on HEA. It's a very powerful data management software. Has a lot of good features and advantages. So the main things that we see on HEA is that, sorry. So whenever you have a database in HA, you're able to integrate with different tools. You can integrate your data. So for example, you can integrate your database with Power BI, with Excel files, even with PowerPoint. You can integrate with different systems. You can make this integration because it works with a SQL Server database. And if you are working with a program that can give you some visualization information, for example, Power BI, and if this program that you're using allows you to connect with a SQL Server database, you can make this integration with HGA because HGA works with SQL Server database. On HGA, you have the possibility to have visualization and analysis of your data in automated reports. So you can make reports on Power BI or Excel files that are automatically updated whenever you have new data in your database. HGA also has some validations and control tools. So whenever you want to import data into the database using HGA, the software, before importing the data, it has some validation tools. So it checks your data to see if everything follows the standards that you define. It checks if there are no duplicate data in the file that you're trying to import. So it does these validations and controls that makes it easier for us to import new data. It allows also to have automation in your data entry. So if you have a system that, for example, you have some telemetry system for groundwater monitoring, and all this data go that you monitor in with telemetry goes to a specific system. You can make a integration between this system and HEA, so data goes to the database of HEA automatically every day, or you can define the time when you want the data to do this integration. And one very big advantage is that HA allows you to have a very flexible database. So let's say, for example, I have a database for groundwater level, and I can store precipitation information and water quality. But let's say that I also want to store air emissions informations in my database. With HA, you can do that because HA has a tool called Template Manager, where you can create new tables in your database. You can create new fields for each table. You can create new columns for each table. And you don't need to be a SQL language specialist to do that. You can change your database structure without knowing anything of SQL. Of course, it's better if you know, because then you have more knowledge on database structures and stuff like that, but it's not something mandatory. So you can create these new tables with different information. It is very easy, and I'm gonna demonstrate to you like how easy it is to create a new table using HGA. And this is a very big advantage of HGA. Its flexibility on creating new table to allow the users to import many different kinds of data in the same database. And also, HGA has a lot of tools for visualizing your data, different tools to import new data, to validate your data. And this makes it very easy for us to work with all the information that we need. And some of the main tools I'm gonna show you here. I can explain a little bit. So HA has a query builder, and this is a very nice tool that helps you to create some SQL queries, and you can have as a result different tables with different information, and you don't need to be a specialist on SQL to create these queries because HA helps you to build the SQL code. So you just have to select what columns do I want in the result table. You just select these columns, and the HA is going to create the query for you, and it's going to create that table for you, and you can save that query on HA in your server, and then you can use this same query whenever you need. And I'm going to also show you an example on creating a different query using HA. It also has a well profile tool that makes it easier for you to see the well profile. once you have this information in your database, the lithology information of your wells, you can use this tool to easily visualize the well profile, and you can export this to a PowerPoint presentation, for example. And I'm sorry, I thought I was with the laser here, but I'm not, but I wasn't, so, but now I turned it on. Um, you have the cross-section editor. So if you have the lithology information in your database and you have this information for different wells in your section, you can create a cross-section using HEA. And this cross-section, you can export and use it as layers a for a modeling software that you are using, for example, Visual Mod Flow. HA has a map module, which is a built-in GIS, and you can use to create some maps and do some spatial analysis. You can have you can create bubble plots, you can have tables of results in your maps, you can create potential metric maps, you can also, and because it has some interpolation tools, and you can do interpolation also for water quality, so plumes of contamination, for example. And you can also import shapefiles and raster files in this map module. It has also a module for 3D visualization, which is the scene viewer. So you can have a 3D visualization and interpolation on HEA. So if you have like a historical monitoring data for water quality, you can have you can see in a 3D this contamination plume, and if you have uh, a long history of data, you can also record a video on the evolution of your plume of contamination. And you can link your information, your data to external applications like Excel and Power BI. And I'm going to show you some examples on Excel files and Power BI or in dashboards that you can create once you have data in your database. Just a few examples I'm going to show you. So this is just this is an Excel file. You can create dashboards in Excel files, and then you can have different informations like how many points were monitored in a specific period, specific year. So you can have a lot of create your own filters of informations here once this information and this data is in the database. And you can have different charts like historical data and well, like all the different charts that you have on Excel, you can use with your data. And all these can be automatically updated whenever you have new data in your database. So like you can use your creativity to build different stuff on Excel and also on Power BI. So this is a dashboard on Power BI. So all the features that you have on Power BI, once you have data in your database, you can just use your creativity and your knowledge on Power BI and on dashboard and to build your own dashboard. And all this will be automatically updated whenever you have new data in your database. So again, you can do like many different kinds of charts and information. You can create a relation between different informations, all using the same database. So for instance, this would be like water level, and on the bottom here, the precipitation that you had on the same period in time. So you can do this cross information analysis. And this is an example of a air emissions report that we built for our client Vale in Brazil. So they have like all this information from all over the world, and they are all gathered in the same database. So they have a lot of different information regarding air emissions in this central database. This is another example. dashboard that we developed on Power BI. This is for monitoring plans. So, for example, if you have a monitoring plan for your area, you have like, let's say 100 wells that you monitor 100 parameters for each well, and you monitor this every month, and it's very easy to lose track of if everything is being monitored as you hired, as you want, as you need. So to make it easier to check if everything is being analyzed as you want, as you need, you can. We created this dashboard to tell the users like how many analyses were made in the specific month that you selected, how many analyses were expected to have been done, and then it does a it checks if everything that you planned was actually analyzed, and if there's something missing. So let's say, oh, you are missing some pH and oxygen analysis for the month of January of 2023. So these reports automatically tells you this whenever you have something missing. And all of this you can only do because your data is in your database. So it's very easy. It's something that is automatically updated whenever you open your dashboard. Um, this is another example that it's a software that we've developed for Vale and for other clients as well. So once you have, this is for water balance. So once you have the information in your database, again, you can create almost anything. This is a water balance tool that is integrated with a database on HEA. So this is just like you can zoom in and zoom out and create your own water balance flux, and all this information of volume of water, it comes from a database for this specific period of time that you select here. And again, if you have a system that is integrated with a monitoring system, so all the data comes automatically for your database. And this dashboard, all this water balance information here, it comes automatically in your screen. So you have automatically this all this flow here, this water balance, it's updated automatically because this information is coming from the database. And it has a module for a flowchart, a module for a map information, and also a module for a dashboard. If you have specific indicators, specific information regarding water balance, it calculates everything automatically and also everything comes from the database. And I'm just gonna propose a short break for us. And after the break, I'm gonna show you a practical example using Hydro GeoAnalyst. So I'm going to open Hydro GeoAnalyst here with you. I'm going to open it and show you the main features, where they are located. I'm going to use the template manager with you. I'm going to create a new table in the database and show you how easy it is to create new tables, create new fields, and stuff like that. I'm going to create a query with you, and you're going to see that it's very easy and we don't need to know anything on SQL language. And I'm also gonna show you a Power BI report. I'm gonna send you a link to a Power BI report. I'm gonna send you in the chat here. You can click on it and access this report on this dashboard, and you can play with the filters, with the with the charts and everything. And I'm gonna pretend that we received new data from a laboratory, some new quality data. I'm gonna import this data on HA, and I'm going to show you how easy it is to import new data and how fast it is. And then you're just going to update the report, and you're going to see that the chart updates automatically. So you're going to see this new data that I'm going to import. You're going to see it in your screen very fast, and this will be possible only because we are working with a integrated database. That's only because we are working with HEA, with this database, and this Power BI is connected with the database. So I'm going to show you these examples. but I'm just gonna propose just a 15 minutes break. So let's come back at so this
Be
is
5 minutes past
1
the hour.
p.m. Yeah, 5 minutes past. Yeah. Okay. I'm gonna send you the link here if you want during the break to work to play with the dashboard. You feel free, and then whenever we come back, I'm gonna open HA, and then we're gonna work a little bit. I don't know if you have if there were any questions on what we've presented so far. I don't think so.
Yeah, there's only
this one here. Okay, so I'm gonna send you the link here, and then on the chat here. There we go. So use this link. When you click it, it's gonna open a dashboard like this one. It's gonna open this one, and then you can click here and work with everything, with the filters, with anything here, and then you're gonna see. And then we are gonna update it later. Okay, so see you in 15 minutes. Hello, everyone. Can we start now?
Yes.
Okay, so I'm gonna start sharing again.
Criou uma licença que ela tem recebendo também esse processo de criar.
So now I'm sharing with you the uh, screen with the Hydro GeoAnalyst. So this is AGA. I already have a project open here. So as Nicola said before, you are all going to receive a 30 days trial license for Hydro GeoAnalyst. So once you install the Hydro GeoAnalyst and activate your license, I strongly advise you to come here whenever you open AGA. I'm going to open a new window here so you can see how it is whenever you first open it. So this is the main window for HA. And so whenever you open it for the first time, I strongly advise you to install the demo project, clicking here. So you're going to click here and then start install the, like, you're going to put like, this is like you can put anything here on the project name, and then you select the folder where your project is going to be. Here for data source type, you choose local database. Okay, so you're gonna choose local database, and then you're gonna hit next, and you're gonna have the demo project installed in your computer, and then you open this project, and then you can play with this demo project. You can do a lot of things there. I'm just gonna go to the project that I had open here, this one. Let me close this window. So, and then once you have the demo project installed and everything, you're gonna have something similar to this. This is not the demo project, it's another project. This is a project that we specifically use for training purposes. So, but the demo project is very similar. You're gonna have all the same buttons here and everything, just with different, some different tables and also some different data. So here on HA, you can see on these bigger buttons here, they are the main modules of AGA. And all the other modules you can see here on the modules menu. So here you can see a lot of modules. And here on project, you're going to have access to some different information of your project, some properties that you can change, some settings of Hydro GeoAnalyst. On the view icon here, you can set to view the start page, which is the page that we were seeing before. And then you can view some different things here, like station data, station list, non-station data, query results, data filter. These visualization tabs here, they are these tabs here. So this is the station list, this is the station data, query results, and data filter. Under the data filter tab, you can see the whole database. You can see all the categories of tables that you have in your database. So in this example here, I have all these categories here. And then you can expand each category and see what table you have under each category. So under general information, you have the station registration table. Under the well history, you have TOC history. Under geologic info description, you have lithology. Well construction, you have all these different tables. Quality monitoring, you have the parameter sample table and the parameter result table. And once you double click it, any of this table, you're going to see all the results for all your tables. So you're going to have all the results here. And on the bottom here, you can see how many data you have, how many lines of data you have on the table that you selected. So for example, on the parameter result table, I have 17,000 lines of data stored. On the parameter sample, I have 2,500 lines. And one very important thing is that under project and Hydro GeoAnalyst settings on the general tab here, number of rows per page. In my here is set to 100,000. Let's say it was only 1,000. You see here that in my parameter sample table, I have a total of 2,000 rows, 2,000 lines of data, but I'm seeing here only 1,000. So I'm seeing 1,000 rows out of 2,000. And then I have more pages here of data. So I have page 1, and if I click here, I'm gonna go to page 2. And if I click again, I go to page 3. This is just so you be careful, because sometimes we don't see this, and then we double click and we are gonna see here only 1,000 results, and I'm gonna say, hey, I have more results. I don't have only this. I should have more. But that's because you're seeing only 1,000 out of 17,000. So if you want to change that, if you want to see all your data in the same table, you don't want all these pages here, you go under project, Hydro GeoAnalyst settings, and then I'm going to put 100,000 here. Remember, this is being recorded, this video. So once you receive your license, you can always rewatch it, like rewatch everything that I'm doing here, and then follow all the steps, and you can do it on your own later. I'm just gonna show you here, so then you can rewatch it later, the recorded video. And so this query result here, it's blank because we haven't executed any query at all so far. I'm gonna execute it one here, and then you're gonna see some stuff here. On the station list tab, you're gonna see all the stations that you have registered in your database. So in this example here, I have 150 stations registered here. If I want to see data specifically for one point, so now let's say, for example, I just selected the DW1. I go to station data. On the station data tab, I'm going to see data specifically for one station. And how do I know which station I'm selecting now? It says here, current station, DW1. And also here on the station picker, you can see that the DW1 is selected. If I click on DW2, you're going to see DW2 selected here, and same if I select another one. Here, I'm seeing data for the station registration data, station registration table. That is under the category of general information. But let's say that I want to see information from another table. I want to see the geologic description. But for this table, specific table, I don't have any information at all. That's why it's blank here. And if I select another one here, let's say this PW001, now I see some information here. I have the lithology for this point here. I have everything here. I select another one. I'm going to see the information from this other field here, this other point here. So I can change the station that I'm selecting from the station picker, or I can come back to the station list and select it from here. So PW1, PW3, so you see changes here also. And if I want to see for a different table, I just select which category is our table, quality monitoring, for example, and from which table. So this point here doesn't have any data at all for this table, but if I select another one, I'm going to see some data here. Here on this section here, you see the project tree. So like here you can see the station groups that you've created for your project. You can see the queries that you created for your project. You can see the different well profiles. So you can see different things here. And first, what's a station group? If I go to station list here, I'm seeing 150 stations here. But let's say that I'm working with a project, I could be working with a project with 1,000 points here. This list would be giant, would be too big for me to find something that I want to see now. So I can create different station groups. So I can uh, try like create specific groups for specific station types. For example, I can create a station group that's gonna show me only the dewatering wells, only the observation wells. So for example, here I have here, I want to see only the observation wells. I just double click on this station group here, and I'm going to see all the stations that are observation wells. I only want to see pumping wells. I just double click here. So this is a way to make it easier for us to see specific points. And all the tables that you see here on HA, so this table, if I go to station data, this is a table. Data filter. This is a table. Everything you see here, they are data that are inside our database, and you can export this to Excel files. So for example, if I want to export this here to an Excel file, I only click on, I can click only on this button here, export, and it's gonna ask me if I want to see some hidden columns that I'm not showing here. Let's say yes, and then I just gonna select where I'm gonna save the Excel file, and then I'm gonna save it, and it's gonna open an Excel file exactly with the same columns here with the data that I'm seeing here. And this button here, you can see that it is in all the tabs here. And under queries here, I have some pre-saved queries here. And if I execute them, I execute them. So for example, hydrochemical concentration, I have her SO4. If I double click it, I'm going to see all the results that I have in my database for sulfate. So I have all the results here for all the points and the result unit and what this only shows me the result, the max value for each point. So this is the max value that I got for this point. This is the maximum. This is the maximum for the DW10. So this is a specific query that was created just to show me the maximum concentration for all these parameters here. The result value here, the unit, pH. So I just double click and I execute. And let's say that I want to change something in my query here that have been previously created. I just right click and there are some different options here. I can edit the query. And here I can do some edits, I can change some stuff. I'm gonna show you later how to work on the query builder. Just gonna close it for now. So you see that now that I'm executing the queries, now my query results tab here, it shows me something. So it was blank before because I didn't execute anything on query. And now that I'm using the queries that I have in my project, I have some queries that are shown here on the tab now. Well profiles. So there are some standard well profiles that come with AGA. You can create your own profile if you want to. Let's open this one, for example. This one, I don't. So you have like all profiles. They have different informations here, different columns here. See, so all of them they change a little bit. So let's use this one, monitoring well. This only has the lithology information. Doesn't have actually the casings and stuff and all those different informations. But as soon as I put the casings information here, I could see I would be able to see the well profile here. So you can play with these different well profiles that you have in your project. And your maps, they're gonna be here under map projects. And now I'm just gonna show you very quickly how how easy it is to create a new table in your database. And this we do using the template manager tool here. So once you click it, you're gonna open the template manager module. It always shows you this window here that is telling you that any change you make in the template manager is gonna be saved automatically. And you can even lose data, like lose something if you do something wrong here. So you need to pay attention when you work with the template manager. So that's why we always recommend people to have only specific people that can have access to the template manager module. Because you can have these different group permissions. You can have people that have permission to import data. You have people that have permission only to read data, and people that have permission to administrate the database. And these people that can administrate, they are the administrators of your database, and they are able to use the template manager. I am the administrator of this project here. That's why I can change everything here if I want to. But if I wasn't the administrator, if I was only with the edition permission, this would be blank here for me. I would be able only to see, but not to change anything. So this is the template manager. Here I can see all the categories, all the tables that I have in my database. On this checkbox here, if I check it, now this table will be visible for everyone, will be visible here on the data filter tab here that I was showing you before, for example. If I uncheck it, this table will now be invisible for the users. So this check button is only for this, for visible or not visible, to be for the table. And now we can see that I have some tables to register some new points, for the well history, geologic information, well construction, quality monitoring. So this is for water quality, hydrogeological monitoring, meteorology monitoring. So I have this different tables for many different kind of data. But let's say that I want from now on to also have data for air emissions in my database. So I don't have any category here for air emissions. I don't have any table or anything at all for air emissions. So I'm gonna have to create a category for air emissions, or it's up to you. You know, I could choose to put this table under a category that already exists here. So, but I want to create another category that's gonna be called. So I just clicked on this button here. This button is to add a category. So I'm gonna create this new category called air emissions. Then I'm gonna create a new table under this new category. To create a new table, I just click on this button here, add a new table. So the table name will be emissions monitoring. You're gonna see here that you cannot use spaces here. You can only put everything together or use a underline here. This is because this is going to be the name of the table inside the database, but later we can change this, and the display name, we can do it differently. I'm going to show you later. So for now, when we create a table, we need to use the underline. And also when we create the columns of our table, we're going to use only also underlines, or put all together. We cannot have spaces. So let's create here all the columns for our tables, or for our table for emissions monitoring. So I'm going to create a field called date, because I'm going to have some parameters that we're going to monitor, and then we need to register what date and time that parameter was monitored for each point. So I'm going to have the date field here. I'm going to have parameter. I'm gonna have the field value. So this is going to be the value of measurement that I measured, and I'm gonna have a field for a unit, the unit of measurement. Here it's selected, link to station table, and this means that I'm gonna have the station column here. So this table is going to be linked to the station table because all these parameters, all these monitoring events, they're going to be related to a specific points, specific stations that are already registered in our registration table. They are shown here in our station list. So we're going to click, keep it selected. So then this table is going to be linked with the station table. And you're going to see that once we click OK here, that automatically HA is going to create this column also called station. So we named all the fields here. We need to set the primary keys of our table, and the primary keys will be, of course, the station. I'm going to show you later, and also the date and time, and also the parameter. So we're going to have all this as primary keys because we cannot have for the same point, for the same date and time, and for the same parameter, we cannot have two different values. That's why we selected this as primary keys. And now we can change the data type. What type of data will be in each of these fields? String means text. So I'm telling HA that all these fields are going to be text fields, text values. But that's not true. Like date, well, of course, I could store this information as a text. I could store date as a text. I could store a number as a text. But it's much better if I tell the database that here on this column here, on the date column, I'm going to have date values. So I'm going to select date here. So this way, HA will allow me to put on this field here only values that are date. I will not be able to put text here in this field here. Parameter is a text, yes, but it doesn't have 255 characters. Parameters have only, let's say, 15 on the maximum. So I'm going to just put it bigger here. So you see there are two options of text here. It's text in 255 and text custom length. So let's choose the custom length, and then HJ asks me what length will be the text that I'm going to put on this column. Let's say 15 characters on maximum. This is also something good to tell the database, like what's going to be the size of the text. Value is a number. So we have two different options here as number, integer and double. Integer are numbers without decimal places. So 1, 2, 3, 4, 5. And double allows you to put 1.01, 1.10, 1.15. So let's select double here. And units is a string too, because it's going to be, for example, milligram per liter or milligram or something like that. So let's select custom length 10. Now we already have all the columns of our table. We have what kind of data is in each column. Now let's click OK here. And now we have like the table name under what category. And we click OK. And now the table is going to be created in our database. Here's the table that we just created. Remember that I told you that when we are creating the table and the fields, we cannot use the spaces or any special characters or anything, because that's when we create the table and the fields, we are telling HA the database names, the names that are going to be stored in the database. Here, database name. But the display name, the name that the users are going to see on HA, they can be changed. So I can put like spaces, I can put like capital letters here. So it's a little bit better to see like this. So we can change that. If I expand the table here, you see the station field, it's automatically created here. And let's put this station field on the top of the table because this is the order of the columns of our table. I can use these blue arrows here to organize everything. So I'm going to put the station on the top. So I'm gonna click, oops, I clicked on the bottom one. So now the station is in the first. It's invisible now. So I'm gonna click here, the checkbox. Now it's visible. Right now, station is not a primary key here, but I'm gonna set it as a primary key because it is a primary key for this specific table. And this I can change by selecting the table and clicking here on this little key here. I can change the primary keys. So I can set station as a primary key, click OK. And the same, I changed the display name here of the table. I can also change the display name of our columns here. So let's say that I want to change the station for station name. I can select date, put like this, parameter, value, unit. So this is a little more beautiful like this. So I can do these changes here. Now, remember when I showed you like the steps to implement the database, one very important steps were to define the standards of values that we want in our fields, in our table, in our database. And we can do this now here on HA. So parameter, we're going to have a specific list of parameters for our database. So I select the field here, and here on list style, now it's selected none. So HA is going to allow anything that I put here as a text. So I can put select as required. Now HA knows that there is a list that I have to follow. I select the generic here option. And now this is exclamation points is because I need to define some parameters already here. So I clicked here. Now this little window opens as it's called the list editor. So I can add here the parameters that I'm gonna analyze for air emissions. So let's say oxygen concentration. I'm not gonna put concentration, just put oxygen uh, particulate material. NOx. So I can put like all the parameters that I'm gonna analyze here. SOX, all the names here. And then I put save, and now HA will allow me to put information only for these 4 parameters here. No other parameters. So if I'm gonna click again here, if I write oxygen in a different way, HA will not allow me to put that in the database. If I write SOX in a different way, HA will not allow me to do that. So this is a very important step. And once I'm done here, in template manager, when I click close, it's gonna reopen the project and the table is gonna be there open, available for me to import new data. And let's say if I created a new table and I can also delete a table, delete a field, or create a new field for existing table. And this is all with using all this button here. If I click on the X button here, I would erase the whole table that I created. Let's say I forgot to create a specific field. I can click here on the add field, add a new field, and let's say record responsible for the record or data responsible or data source. So because I want to see what register in my database, what's the data source of that data that I'm importing. And this I can leave as a text, a long text, or I could limit the data source for, I don't know, 100, for example, and just click OK. And here I have all my new field created, data source. And now, okay, I'm done with my table and I click close. It's telling me that the project's gonna be reopened because I made some changes in the database structure. So it reopens the database. Now, if I go here on the data filter tab, here's the air emissions table. with all the columns that we just created. It's empty, of course, because we still don't have any data updated here, uploaded in the database. And using the data filter tab, it shows me here the database name of the columns, not the display names that we selected. So for example, here, meteorology shows the name of the fields of database name. But if I go on the station data tab, air emissions, now I see the display name that I selected on template manager. And of course, it's empty because I have no data of air emissions for this station that I'm selecting here. And there are different, so now I'm gonna just show you the how to create a query. Something also very easy to do. So I just go to the query section here, right click, new query. So it's gonna ask me, oh, what's the name of this query that we are creating? Let's say it's iron. I'm gonna put a number v2 here because I have already iron query here created. I just click OK. So it always starts the query with already one column, the station name. So this on display fields, this is where we are gonna see all the columns that we want in the result query, the result table. So far, if I save this and execute like this, it's going to have only one column. It's called this row ID column is a standard. It always comes, but I only have one column, station name, because in my query here, I only have this column selected. So let's select other columns. I want a table that shows me all the results of iron, of the parameter iron that I have in my database. So what columns do I need for this? I need the station name to know from which station I'm seeing the iron result. I go here to the quality monitoring category where I will see the water quality results. Under the parameter sample table, I'm going to select sample ID because each sample has a different ID, and I want to see which ID is that iron result that I'm seeing. I want to see the sample date to know in what date that result was collected. And now I go to the parameter results because this is where the results are. I'm going to have the chemical name here, this column, and I also want to see the result value and the result unit. So this will be the columns of the table that we are going to create. But now, if I execute this, query like this, it's going to take a while to open. It opens actually very fast, but it opened with all the parameters of our database. See, all the parameters. Because I didn't tell HA that I only want to see iron results. I still didn't tell HA in anywhere this information. So now we have to tell HA, I only want to see iron results. And how do I do this? I use this conditions tab here. I'm going to use the conditions here. And the conditions are that the chemical name has to be equal. And then value, I'm going to choose the iron, which is Fe. This is the iron name on my database. And now if I save and execute, now I'm seeing all the results of iron. And I'm seeing the results of iron for all the point stations that I have in my database. But let's say that I only want to see the results for observation wells. I don't want to see for the other points. I just want to see for observation wells. So I now have a new condition that's going to be the station type has to be equal observation well. The station type information is under the general information, the station registration table. This is the station type. So I just click and drag here, drag and drop. So station type has to be equal. And here I'm going to select observation well. You see there's an exclamation point here. It's because now I have more than one condition, and I have to tell HA if it has to follow both conditions or just one or another one. This is the difference between and or. If I select and, I'm telling HA that it has to follow these both conditions. It has to be equal iron and it has to be observation well. If I put R, I'm telling HA that it has to follow one of the two conditions. It has to be iron or it could be observation well. But I'm going to choose and because I want both conditions to be followed. It has to be iron, it has to be observation well. Now when I execute it, I'm seeing results for iron only for observation wells. And if I want to export this and see on Excel file, I click export. I select iron observation wells. I save it. And then it asks me if I want to open the Excel file now. I'm going to say yes, I want to open it. And it's going to open the Excel file here. And once on Excel, I could do whatever I need with this information here. And our query is here. So if I execute another one, I can execute it again here. And once I import new data, I'm going to see this data here in this table in this query that I created. And if later I want to make some addition on our query, I just right click, edit query, and then I can change something here. I can change anything. See on this alias column here, I can change the name of the column here. So this name here, I can change. You can change here like sample date. Let's say I don't want this underline. I want space. I don't want sample. I want space. So I can change chemical name. I just want to put, I know that it's iron. I'm going to put iron here. Result. So you can do anything here in the alias option. Here on expression, you cannot change, but alias you can change. And if I execute, now all the columns, they change it. Okay, so this is how you work with Query Builder. Now I'm going to show you two different ways of importing new data in your database. One way is manually. You can go like, just 1 second, I have a frozen window here. I have a problem with my connection here, but while I have this problem, I sent you before a link to a Power BI, to a dashboard. This is the dashboard that I sent you. So if you go under the different tabs here, you can see like different stuff that are, you can check on this report. You can change filters, change location, change the station names. And this dashboard is connected to the project that I was showing you on HEA. So you can change like specific points here. And under the hydrochemical time series plot, you can see here that we have data only until September 2020. So if I change the point here, September 2020, if I want to see the iron information here. And then you have different informations here. So you can feel free to play with this report here whenever you want. But for now, let's just pay attention on this, that we only have data until 2020. So now I'm going to just pretend that I have a laboratory that does all the analysis of the area that I'm working with. And let's say that this laboratory just sent me a new series of results for some points in some parameters. They just sent me by email all this data, and I'm gonna import this data on HEA, and I'm gonna ask you to reopen your dashboard just by refreshing it. They'll just like by re-clicking here, and you're gonna see that the charts here, they're gonna be updated. They're gonna have new data, like new data from for until 2022. So let me see if I got the connection back here. Yes. So before showing that, I'm just going to show you how to import or register new data manually. You can do this on, you can create new points, new monitoring points by clicking on the, I'm going to execute the all stations here again. So now I'm seeing all the stations. If I'm on station list and click on the plus button here, add new station, I'm going to add a new station in my database. So it's a training station. I'm gonna put, you can put the coordinates here, and like the elevation. You can, what kind of point? It's an open hole, location description, training area. So you can put like all the information here. You don't need to put everything. You can leave some blank spot, some blank fields here. If you click on save, now I have this new station registered in my database. This is our new station I just created. But I'd say, oh no, I did a mistake here. I was not supposed to put this station here. I just click on the X button here, and I'm gonna delete the station from our database. So this is one way to register a new point. And you can also import using the import data module here, and you can import an Excel file. You can also put some new any new data like air emissions, for example. So let's say that for this point here, I did one monitoring, and I just click on the plus button. I select which day was the monitoring. Let's say it was today. What parameter I did monitor. Let's say it was particulate materials, and I measured the value of 10, and the unit was, let's say it's microgram, but I don't have the micro here. Microgram per cubic meter, let's say. Data source was, I don't know the data source. I'm just gonna leave it blank. So far in this example, I just click on save. Cannot set the, oops, it's too big. The name of the parameter is too big. Like, remember that we set the maximum size of the field was, I think, 15 characters. So this exceeds, so that's why it didn't allow me. So I'm gonna put oxygen here, and now it's gonna save. And now I have this new data registered in my table here. If I go under the data filter tab and I execute the air emissions, you can see the data that I just stored in the database. So this is another way, but it's not really used because people don't usually put data manually in the database. Usually people use Excel files or EDD files. And what are the EDD files? They are files that contain a lot, could be one data or a lot of lines of data that are pre-validated. So for many of our clients, they have all their contractors, the laboratories, for example, they already know how to use the Quick Checker. Quick Checker is a free software from Waterloo that is connected with AGA. It's from this V button here. And the labs already are used to the quick checker, and this is a software that knows how is your structure, your database structure. It knows what list of values you can put in each column. So when the laboratory wants to send new data for our clients, they go to the quick checker to see if all the data is under the standards of our database. If everything is okay, then quick checker allows you to create what we call the EDD file. So they generate the EDD file and they send to our clients the EDD files. That's what I'm gonna pretend here. Let's say that the laboratory just sent me the EDD file with a lot of historical data that they have. So for example here, in my Outlook, this is the email that the laboratory just sent me with the EDD file. This is an EDD file. So I just have to save it in my computer. Just go here and save it. So I saved the EDD file in my computer. Now I go to the HEA. I'm gonna open the import data. So now HEA asks me how I'm gonna import this data. Probably lost connection again because I get a frozen window here. So remember that we only have data until 2020. Just wait a second until I get the connection again here.
Maybe while you're waiting for that, we did have a question in the chat here. Maybe get a second to answer.
Yeah, sure. We have a question here. Let me see. Quick question. How to establish a database to plot a parameter profile, pH, at a sampling location at different depths. So a database to plot parameter profile. So okay, pH for a sampling location at different depths. Yes, you can do that. Let me try to. I'm gonna try to reconnect here. Because like in HEA, you can have on the sample. Yes, multi-level. Yeah, like you can have a multi-level. Yes, like a multi-level well. And for each well, you're gonna have these different results for pH. And this is very easy to do. And also you can have, for example, if you do some monitoring in a lake, we also have some examples on that. And then you have like you collect water from different depths of that lake in the same point. And on the sample table, you specify that what's the depth of the water that you collected the sample. So it's from the surface or on the bottom from 2 meters depth or whatever. And so you have that information in your database. And once you have that information, you can have a dashboard that you can filter if you want to see, for example, if for a multi-level monitoring, you can say you can select from what depth you want to see the data. I want to see from the surface, from the bottom, from the middle. So you can choose that because that information is in the database, so it's possible to create the filter. So I could have here, for example, another option to filter here to say that I only want to see information from let's say that this well here was a multi-level. It has a DW A, B, C, and D. So I only want to see the results from the A portion of my aquifer, for example. So it's going to show only here the information from the points that are in the A depth of my aquifer. I could have a chart. On this example here, I'm seeing information for only one point, but I could have a chart that has information for multiple points for a specific depth. So like it's just a matter of using your creativity. Once your data is in the database, you just have to create the chart that you need, and it's going to be connected to the database. Because this information you can easily put inside your database, like multi-level parameters. I don't know if I answered you. That's okay, but if I didn't, please just ask me again, and then I'll try to explain a different way. Another question: installation included database. Once you install HA, it installs in your machine a local database. Yes, okay, and it is a SQL. And when you select that install demo project, and I told you to select the local database, it's gonna put your data in that local database. But if you know a little bit of SQL and you have your server, you just have to tell HA in which server you want that database to be created, and HA will create that database in the specific server that you told HA to create. How to create a table for multi-level monitoring. You actually don't need, if you want to create a table, you can using the template manager, create a new table. Or for example, on this example here, quality monitoring parameter sample. This is the parameter sample. So let's say that this DW here has different levels, different depths that I could have my sample. So I could create here, for example, gonna open my template manager, quality monitoring, parameter sample. So I have all these fields here for that table. I probably don't have here depth. Yeah, I don't have here, but we can create another field here called, let's say, depth. And it's gonna be a number, so double. I could start as a text. For example, in a lake, if I only do like surface, bottom, and middle, we always recommend to put as a number. So because it's a number, the depth could be 1, 2, 3 meters depth. So I couldn't put depth. Or if, for example, if you want to put like for the aquifer portion, I don't know if you have a name for that depth of the aquifer, you can use as a text too. Then I click
So,
OK.
Christian, this is Vivek. Can you hear me?
Yes.
Yeah, it's a multi-level monitoring kind of WES-based system in different aquifers. So maybe depth will be integers, let's say. Anything.
Depth. Sorry, repeat again. Depth would be.
Yeah,
sorry.
yeah. So depth can be an integer, but my point is at a certain depth, it's a little bit complicated, It's not only the one-time monitoring, and then also we want to monitor it over time, right? So
Yeah.
it's a multi-dimensional.
Yeah. Okay. No. Yeah. So
yeah, thank you.
In this example here, for example, I just created a new field called depth. It's just reopening because I changed the database. Quality monitoring. Now I have the depth here. So, and yes, I can do like this. It's not just for one monitoring event. It could be for a historical event. Could be like for 10 years. For example, let's say this is for 5 meters depth. This was 5 meters too. This was also 5 meters. And this one is 10 meters. This is 10 meters. And they could be in the same date. Like in the same date, I could have a sample for the depth of 5 meters and the sample for the depth of 10 meters. So I could have, like, in this example that I'm quickly showing you here, like they are different dates, but they could be in the same date. So 10 meters. So like this is where you tell the database from which depth is each sample, and you could have historical data for each depth, like for this point here, for the depth of 5 meters, I have these 3 results here. It could be 50 results, could be 1,000 results. And for the 10 meters depth, could have like more 1,000 results. And you could do some comparisons, like between the 10 and the 5, you could do comparisons between them. And this you could do using the dashboard, using dashboards, using Excel file, for example. You could create a automatic Excel report connected to the database that does this comparison between the 2 different depths of this point here. And you could have, well, not here. For example, in this report here, you could have like a chart on the top here that shows you the results for the 5 meters, and on the bottom the results from the 10 meter, and then you can compare the two charts, or they could be in the same chart, like for different lines, one line representing the 5 meter, one line representing the 10 meter. So once data is in your database and if it's well organized, you can do many things like in Excel or Power BI. But I don't know if this answers your question that you can have, yes, you can have different depths for the data you collected.
Yes, Christian, but what I wanted to be clear is, let's say we have monitoring at 5, 10, 15, 20, 15, I mean 50, 100, at certain depth. And I wanted to see the sample date along the rows. So you can go by column. Let's say if we have a periodic monitoring on a weekly basis, so you need to have a date of sampling along the, I think, rows, right? So you can continue, and then plot it like in Excel. So it's basically, I was trying to find the way, how can I do it? Not doing in Excel, just in Hydro GeoAnalyst. Yeah.
Okay. No, yeah. I know you like your HEA you're gonna use to import data to store your data. But it needs to be clear for you, like the difference between data and information. Because you have the data is here, but the information you extract from your data, that's where you're gonna use Excel file, Power BI, or some other tools that HEA has, like map module or the plot module or stuff like that. You can have, like, you have some visualization tools in HEA, or you can use Power BI or Excel. So you're not gonna be free from like Excel or Power BI.
Yeah, my question was around the long-term monitoring, like a closer project or something, mine closer project, because you continue to monitor for many, many, many years.
Many years,
So,
yes.
Yeah. So anyway, thank you, Christian. Yeah. Thank you.
Okay, yeah. You're welcome. So let's go back to the EDD there. So if you remember, I downloaded the EDD file. I'm gonna import now. So here I select what kind of data I'm importing. Is it from an Excel file or EDD file? So it's an EDD file. I'm gonna browse it. So here, it's gonna analyze the data to see if everything is okay. Okay, everything's okay. I got a lot of green information here. I'm importing 250 new samples and 3,000 new results. I just confirm by clicking import and close. Now I have all this new data here. If I execute that iron query that we created before, you can see that now we have some data for 2022, 2021. And I'm gonna ask you just 1 second. It's updating here. Now, if you reopen your dashboard, just refresh your page or just refresh here. Now, you see here that we have data for 2022. So the main thing here, like the beautiful thing here is that I have this dashboard created. I have this chart and everything. Like I could have like indicators in my dashboard, like numbers, like if it's everything is okay or whatever, number of parameters that are uh, that are following the legislation and stuff like that. So I could have anything here, any kind of information that I need on my screen, and it all updates automatically once data is in my database. So I received the email from the laboratory. I just put in my computer, open HA import, like, and you just saw that everything was very quickly. I did a little slow just to show you how it is, but once you know it, you do it very quickly. You just reopen your Power BI and the dashboard is already updated. You have the chart here with the data that was updated like a few minutes ago. And if you want to see just specifically that data, you can like use the filter here just to see that new data here. Oh, now I see that I have some values up above the limit here. Let's see what happens. So you can have access to the information in a much quicker way than before. So that's a very, very big advantage on using a database and having some kind of report or some kind of dashboard or something connected to your database and automatically updated. And that's it that for today, guys. So if you please have more questions, anything, please feel free. I see that I have some questions here from Tom. Can Power BI Excel connect directly to a query in HA? Or do you have to connect to each of the database tables separately and then create the joins and queries? No, you can have a specific query. You don't have to connect to each table of your database. You can do this connection using a query. Yes. Okay. You don't need to connect to each table of your database and then do a script or whatever with your data. You can have this query already. I don't know if I answered you, Tom, but I think that was your question, right? One more question. Can HA upload a continuous monitoring data? Formation pressure and temperature that comes in REC file format and visualize. This is not a different types. Okay. REC file. What I'm sorry, but I don't know what our REC files are. Are they like? Because I'm gonna show you the different options of HA, and maybe then this way it helps you. Under the general tab, you can import any data on Excel. So it could be an Excel file, CSV file, any kind of file that opens in Excel, and Access files. You can import ADD files. That's the file that I just showed you. You can import file using the mobile EDD, which is another module of HA. You can import diver files, LAS files that comes from divers, and some images also you can import. But I don't know if about REC files, Vivek. I'm not sure how.
It's okay.
Kind of
Yeah, it's a special format, but it can be converted into CSV or other. It's like a text file. Yeah.
Okay.
File.
Okay. Yeah, text files you can also import.
But there is a possibility HA can upload, right, big amount of monitoring data and visualize.
Yes,
this is over time. Yeah.
But one very important thing, your data has to be in the standards of your database. Okay, so I don't know, let's say if it's all like if you have like an Excel file that has a lot of tabs and information, they are gathered like, I don't know, in different formats, or it doesn't have a pattern, you will not be able to import your data. You need to give some standards to your data before importing. Because, for example, just gonna show a quick example on how it works when I import. Oh my God. It froze again here, I think. Hold on, I got it. I'm gonna just select an Excel file here just to show you how it is to import as an Excel. It's a little slow here. I'm afraid I lost connection again. Yeah. Okay. Because basically I'm gonna tell HA, because I have my Excel file. That Excel file has different columns. Okay, it's a spreadsheet, and I'm gonna tell HA that, oh, this column here on my Excel file, it has informations for that column there in my database. So I'm gonna do like I'm gonna tell HA from which column I'm gonna get each information for the specific table that I'm importing in database, that I'm selecting to import the new data. So it's a little bit harder than importing ADD files. ADD files I did very quickly, but to import Excel files, that's this. It's very easy to, but I just have to be careful to tell HA, okay, the value for water depth, it comes from this column here on Excel. The value for the station name comes from this column here. Okay, let's see if now I get it here. So I tell HA that the information that I want is on sheet 1 of my worksheet. This is just a preview from the Excel file that I'm importing. And then I just tell HA, like, it's data for, I don't know, let's say quality monitoring, water, and it's parameter result, I don't know. So this is the parameter result table for the database. So here on source, I will see all the columns that I have in my Excel file. This is in my Excel file. Destination is my database. So this is the columns of this table here that I just selected. I selected parameter result in my database. This is the parameter result table. These are the columns of my database. So I'm gonna tell HA, okay, the information, like the station information I get from this column here, station name. This is the column in my Excel file. Sample ID, I get on the sample ID column of my Excel. It automatically the HA automatically selects some columns according to the name. If they are the same name of the column of the database, it automatically relates. And some of them are blank because HA didn't identify in your Excel file any column called qualifier. And then I come here and yeah, okay, I don't have qualifier, just leave it blank. I have result value here, have result unit, comments. Now I don't have any column for comments, and then I just hit next and it's gonna import this data. So it's important that your CSV file or your text file has this standard, like has the information that you're trying to import. So if you are, for example, you said formation pressure and temperature, uh, I don't have a table here for that, but let's say I had a specific table for that. Like one column would be temperature, one column formation pressure, for example. I would just have to tell HA, okay, the temperature information you're gonna have from this column here for that file that I'm trying to import. So this is just something to be careful. So guys, I don't know if you have any more questions.
Yeah, I also wanted to show off the help file.
Oh yeah, sure. Please go ahead, Nick.
Yeah, so I guess you guys can keep asking questions, but I don't know if you can see my screen. Christian, are you able to see it?
Yeah, I'm
Yes.
seeing your
Okay,
screen.
yeah, sorry, I had a big presenting bar is blocking a lot of things. Anyways, so what I just wanted to highlight quickly. So I expect that a lot of you are probably going to be new to HGA or maybe don't have that much experience. The help file that comes with HGA is very comprehensive, so you access it by going to help and then contents, and that will open the web help. And particularly here, so there's quite a lot of documentation at every module. Basically, every button in HGA is documented here, but in particular, this HGA Plus demo project tutorial. If it's your first time using HGA and you're installing from the demo license, I would strongly suggest one of the first couple of things that you do would be to open the demo project tutorial, maybe have it on another screen or something. And this tutorial comes with several different parts that kind of walk you through the basics of the interface, as well as many of the different modules. So, for example, like in this managing data, it teaches you how to manually enter data, but as well how to import data. So, how to use the import data module. But so I'd recommend that you go through these. They've got step-by-step instructions. Also as well, so like if you got questions about how to use the list editor or something, you can just go to search list editor, and again, usually anything that's in the program will be documented. There's like really quite a lot here, so that's something I want to highlight. Yeah, if for kind of more in-depth training, if you want to, we also have paid trainings, Waterloo Hydrogeologic and WST collaborate to put these on. So if you're interested in that, you can contact any of our sales teams. Yeah, so that's just all I wanted to share is very quickly. And I realize my camera's off. I guess if we have any more questions. Doesn't seem like it. So I just wanted to thank everyone for attending, and a special thank you to Jefferson for helping with the technical issues, and thank you for everyone out who persevered getting to this meeting.
No problem, Nicholas. Thank you, everyone.
Okay, thank you, everyone.
Oh, actually, Oleg, that's a great question. I'll quickly show how to get that. So if you don't have HGA installed, you can access the user guide. I meant to show this off. If you go to waterloohydrogeologic.com, and I believe under support, documentation, and licensing, if you go to Hydro GeoAnalyst and click documentation and resources, there's the user's manual. So click this, it just open up the same exact page that I was just looking at. Also, I'll just paste it in the chat. Problem. So yeah, maybe I'll give another minute or two for questions, but Okay, well, I guess if there's no more questions, again, thank you everyone for attending. It's my 5th time saying that. I was happy to see how many people showed up. And yeah, I guess have a good afternoon.
Have a good day there.
Everyone.